Jill Gotthelf. I'm a principal at Walter Sedgwick Architects, and I'm co-chair of the APT Technical Committee on Sustainable Preservation, and I'm a preservation architect. The Technical Committee on Sustainable Preservation began out of a Halifax symposium where we realized that there was a growing concern about sustainability from a holistic perspective, not just energy and environment, but also community and social equity, and how our heritage buildings played into this movement, and what we should and shouldn't do, as well as the issues of climate change and the impact they're having on our buildings. And it was really a very widespread look at our heritage buildings and issues of sustainability and environmentalism. And from that, over the years, the committees looked at addressing issues from rating systems to climate change, education, preservation programs in the schools, and are they addressing issues of sustainability. And now we've also moved into focus of policy. And there was a symposium in Montreal that addressed theoretical issues. And over the last 2 years since that, we realized that we at APT have a specific expertise in technology and in the technical end of these issues. And looking at all the organizations that have been working on sustainability, there's other organizations who really are public policy organizations and addressing many of those concerns, and that we really needed to focus on some of the technical issues so we could offer our expertise to the entire field addressing sustainability. And with the coming out of all of these new codes, especially the upcoming International Green Construction Code, we realized that many of the concerns dealt with energy and our envelopes, and we, deep down in our hearts know that historic buildings are not the energy hogs that they're made out to be, and the advantages of thermal lag, and that buildings built before World War II had to address environmental issues because we couldn't design the environment out of our building. And that they really did most of what these codes and LEED and all of the rating systems were asking for already. And it's just they've been maligned or they've been altered, these systems have been taken out, people don't understand how they work. And so one of the things we wanted to address is envelope modeling and monitoring and performance of our existing buildings to get real data that show how our buildings work. Modeling of new buildings, we're finding buildings are modeled and then they don't perform the way they're modeled to be. We with historic buildings have the advantage that we have real buildings that we can go out and actually do real models based on performance testing. And so the decision was that now was the time for a 2-day workshop to discuss what tests are available for historic buildings, what information can we get and show, and then how can that information be transferred into a model so that we can generate data that we can take to explain how our historic buildings work, what systems are in place, what happens once those originally designed systems are restored, how does the building perform by itself, and now what intervention really is necessary. And you'll find that the designs of the systems vary greatly when you really understand actual performance and then design an intervention rather than a model. We used the Central Presbyterian Church here in Denver. That was an ideal building because it's a historic masonry church with a 1960s, 70s cavity wall addition. And we were able to both model the cavity wall addition and the historic portion of the church and look at the differences in how the two perform and the different decisions that you'd need to make based on the two different building construction types. And there was a series of pre-testing that was done about a month ago so that we had a baseline testing as well as doing the hands-on testing at the workshop, so that we had a report of the testing to discuss at the workshop as well as to physically do the hands-on testing. And that included looking at, this was a building where the original passive system had been closed up, and we looked at at how the building was performing now with that, and then discussed from our knowledge of how the system originally worked, this whole chimney effect and reopening of the passive ventilation system, what would be gained by restoring the original system, and whether that's a better solution or a newer intervention. Well, interestingly enough, our findings were actually giving us real data for what we already knew about how thermal lag works, and based on modeling of looking at historic buildings and then modeling how the heat transferred through the building, we've actually started to look at putting insulation on as being a disadvantage, not just from what we already knew about creating dew points and moisture, but that it also didn't allow that additional heat to transfer into the space. It didn't allow us to gain the advantage from the thermal lag that we had naturally. And so it gave us a better understanding of what we already knew, how these buildings performed, in a way that we then could bring it on to our building stewards, and rather than just trusting us, they could actually see. Yesterday in the church, we actually had blower door set up for the participants to work through, and they watched the setup of the blower door, an explanation of the fans, how we pressurize or depressurize the building, through turning the fans on, having the system work, and then walked through with smoke so that we were able to identify locations where there were drafts. As well, then there was equipment for doing thermal performance, being that this is in October, the results on that would not be as dramatic unless you were hitting a part of a building that happened to have, the heat on and steam. Whereas on a really cold day in the winter, you would see greater differential, or a really hot day in the middle of the summer, you would see a greater thermal differential when we went and tested all the walls. But it gave a relative understanding of one surface to another surface. And that's been a discussion throughout this workshop, that all of our testing devices have reached a certain point of accuracy. They will continually grow to become more accurate, and there's a certain amount of user failure and a certain amount of changes in levels of accuracy depending on the sophistication of the equipment used. But every one of them are good tools for relative performance and understanding, because if you're using the same tool in one place and another place, your relative performance is still the same, even if its actual physical number that it's reading out is not. We have a range of instructors that include, yesterday, our leader in the hands-on testing is with a company here in Denver that's Lightly Treading, and they go in and do energy audits and evaluation and testing. They themselves are not trained architects, engineers in developing the new systems to make changes. They are very well versed in collecting the data and analyzing the performance of the building and developing an instruction on key areas where efficiencies can be added. We added to that several engineers ranging from structural engineers, mechanical engineers, and engineers that are also working in the energy modeling field, who then have been able to show us how that information that we gathered can be put into models and analyzed, can make informed decisions in our evaluation of cost benefits and life cycle cost analysis, and then can also discuss the pros and cons of making those decisions, understanding holistically how the building systems work, making certain changes are going to have impacts on other decisions that you make. So we've really had a nice range. Yes. This workshop is for CEU credits from the American Institute of Architects and the NEECES, which is the engineering, and the Ontario Architects. So it offered a full range of CEU credits. The entire workshop was videotaped from a grant from NCPTT, which we will take the 2 days and condense it into a 1-hour learning module that we would like to then make available to outside of APT as a